Hey everyone, welcome to Hawks Tutoring. I hope you're having a great day. Today we are doing Chapter 6i, Question 11. So this is your implicit differentiation topic from your differentiation chapter. This is one of the hardest questions in this topic. So hopefully after watching this video, you're able to do the question and more importantly, you're able to understand why we did the things we did. Okay, so let's have a go at this question. Question 11. The equation of a curve C is x cubed plus xy plus 2y cubed equals to k, where k is a constant. Already from this equation right here, you know that it is an implicit diff kind of equation because there's x and y all over the place, right? So part A already is find the gradient in terms of x and y. Well, if you want to find dy dx, we differentiate both sides, okay, in terms of x. So d dx x cubed plus xy plus 2y cubed bracket, and then we d dx the other side as well, which is k. And of course, if you derive x cubed in terms of x, you get 3x squared. If you derive xy in terms of x, what should you get? Well, think of this as a product rule. That's function 1, f, and then y as another function. So x as f, y as g. If you use product rule, you should get f dash g plus g dash f, right? So if we're deriving that, we're deriving x first, so which is f. So we get 1, and then 1 times g is y, so you get y. And then you add g dash. Now, when you derive y, you should get, so d dx of y, with implicit diff, this is actually quite important. When you derive y in terms of x, another way of writing that is d dy of y times dy dx. Now, how does that work? The dy cancels out, and then you have d dx of y, which is what you originally have. The good thing about doing this is now you can actually derive y in terms of y, because d dy of y is 1. And then 1 multiplied by dy dx gives you d dx of y. So you can actually now derive y in terms of x, which will just give you 1. So derive y first, so d dy of y, that is 1. 1 multiplied by dy dx. So 1 multiplied by dy dx, that gives you g dash, okay? Now we just need to multiply by f as well, which will be x. Then we do the same with 2y cubed. Here's a shortcut, guys. You just derive it in terms of y. So in this case, we get 6y squared, and then just put a dy dx at the back, okay? So that's how you derive y in terms of x, using implicit diff. And then d dx of k, d dx of a constant is always 0. So you're good with that. And then all we need to do now is solve for dy dx, right? So group them all together. Dy dx would be x plus 6y squared equals to 3x squared plus y. We move it to the other side, so we get negative 3x squared minus y. And then dy dx would equals to negative 3x squared minus y, everything divided by x plus 6y squared. Okay, so we just divide the x plus 6y squared, we just bring it to the bottom. Okay, so that is part A. Find dy dx in terms of x and y. This is in terms of x and y, we can't simplify anymore. Okay, let's move into part B. What does part B say? Okay, this is one of the more complicated part of implicit diff. So let's read it. The curve C has a tangent parallel to the y-axis. Ooh, what does that mean? So let's imagine the curve C looks like this. I don't know what it looks like, but because it has curve C, I'll just draw it as a C. And then it has a tangent parallel to the y-axis. Now, what is parallel to the y-axis? This is the y-axis up here going vertical. The tangent parallel, so a line parallel to y, would be x equals to something, right? So you know the vertical line equation. So x equals to a number. X equals k, x equals c, we don't know, right? But it is parallel to the y-axis. So this tangent would look something like this, okay? And then it's going to touch that the curve at one point. Right. Then we need to show that the y-coordinate at the point of contact, so we need to show that this point right here, it's going to be at x something, and then it's going to be at y something. Point of contact satisfies this equation. So we need to show that the y-coordinate, this coordinate, is equals to 216 y to the power of 6 plus y cubed plus k equals to 0. It satisfies this equation. So you're thinking, how does that work? We have a vertical tangent line to our curve, which has this equation right here, and then how are we supposed to find, you know, the actual equation? Like, what is this equation? And then we also have to show that the y-coordinate is equal to this. So there's a lot of things going on, but let's do it step by step. The first thing is there's a tangent, and that tangent is vertical. So that means the gradient is essentially undefined. How do you get an undefined? Well, this is our gradient formula from the curve And if you want to get an undefined gradient, you let the denominator equals to 0. So in this case, x plus 6y squared equals to 0. That means you get an undefined gradient. So in that case, the vertical line, right? So we can bring the 6y squared over to the other side, and you get x equals to negative 6y squared. And then if you haven't done implicit before, or if you've only done methods, which most of you should have done only, then this is really confusing, because normally you'll get an answer, right? X equals something, and then solve it to get a line, y equals mx plus c, solve a point, get c, and all that. But the problem here now is x is equals to y. It's not x equals to a number, or not y equals to a number. It's actually x equals to another. It's like an equation again, okay? So how does that work? So it's this, what this equation is saying is the gradient is only vertical, or the gradient is pretty much undefined only when x equals to negative 6y squared. So maybe for example, when y equals to 1, then x equals to negative 6, right? So only at this point will the gradient be undefined. And then of course when y equals to 2, so 2 squared will be 4, 4 times negative 6 is negative 24, and x equals negative 24, only at these points will the gradient be undefined. The problem though is, of course, you have infinite values, right? Y equals 3, y equals 3.5, y equals negative 1, you get all these other points. We want to find only points specific to this curve. So yes, there's an indefinite amount of points that you can get to get undefined lines. But we want only points that's on this curve, right? Because we want to find the intersection point. So what you do is, this is equation number 1. If you want to find an intersection point, then equation number 2 is actually your curve, which is x cubed plus xy plus 2y cubed equals to k. So that's your second equation. And we want to find the intersection, right? So it literally says show the y coordinate at the point of contact, so which is the intersection point. So you do simultaneous with these two equations. And if you do the simultaneous, in this one, you do the substitution one. So whenever you see an x, replace it with negative 6y squared. So here's an example. Negative 6y squared cubed, because you're replacing with the x. And then x again, negative 6y squared times by the y. And then plus 2y cubed equals to k. Let's expand everything. Negative 6 cubed would give you 216 with the negative. Y squared cubed is y to the power of 6. And then negative 6 squared y, negative 6y squared times y would be negative 6y cubed plus 2y cubed equals to k. And you can already see this equation coming up. So move everything to the right hand side. That is 216y to the power of 6. Move that to the right hand side. Negative 6y cubed plus 2y cubed is negative 4y cubed, but then you move it to the other side and you get plus 4y cubed, and then plus k, because we don't need to move k. And then it's equal to 0, which solves part B. And there we go. This is your y coordinate. The x coordinate is just x. This is x. That's your x coordinate. The y coordinate is this one right here. Okay? So it must satisfy this. That is part B. Right. And then let's move on to part C. Now, what does part C say? Hence, show that k must be less than or equals to 154. What does that mean again? So this is why this question is confusing. So hence, show that k is less or equals to this 1 on 54. Right. Our tangent only works, so we only get a point of intersection for this equation right here. So the y coordinate will be this. If, for example, you don't get an answer, so when you try to let this equals to 0 and then you solve for y, if you don't get an answer, so let's say you solve for y but then there's no solution, so no solution, then that means we don't have a y value where on this curve where the tangent is vertical, right? So the gradient is undefined. So if no solution would mean no tangent, right? Because there's nothing, there's no point where on the graph there'll be an undefined gradient. So no solution, no tangent. What we want then is one or more solution. And if you have a look at this, it looks very familiar. That is your, 6, so y to the power of 6, y cubed. You can write it as 216y cubed, and then this y cubed can be squared, and then plus 4y cubed, see, that's to the power of 1, and then plus k equals 0. So this is pretty much a quadratic in disguise, and whenever you see a quadratic, you want no solution, one solution, or two solution, you use the discriminant formula. So discriminant is b squared minus 4ac. We want to have a tangent. We want to have at least one tangent. There can be more than one tangent, so that's two solutions or one solution. That works fine as well. We want b squared minus 4ac, the discriminant, to be bigger than 0 or equals to 0. We do not want less than 0 because this does not work. This will give us no solution, meaning no tangent. Right, so if you do that, guys, find the discriminant, then what you actually get, or let's have a try here. What is b squared? So b squared is 4. 4 would be square would be 16, and then minus 4 times 216 times by k, right? And then we want this, well, that's a discriminant. We want this to be bigger or equals to 0, okay? So let's solve for k. 16 minus, well, let's see, 4 times 216, that would be 24, 2, 4, 6, and then 864, k, bigger than 0, and then we solve for k, we move it over to the other side, so that means 16 is less than 864k. Right, and then we go 16 divided by 864 less or bigger than equals to k, and if you simplify this, guys, you should get 1 on 54. So k is less than 1 on 54, which is what we need to show for part C. See, right here, hence show that k is less than 1 on 54. This is what we did, and the reason why this worked was our discriminant. Discriminant bigger or equals to 0 means we have a tangent, a solution. If it's less than 0, then we have no solution. We don't want no solution, because part B says we must have a tangent parallel to the y-axis, right? So that means there is a solution because there's a tangent. Okay, so that's part C. And then part D, find the possible value or values of k in the case where x equals to -6 is a tangent to C. And if you want to solve for part D, so for the value of k when x equals to -6, what you can do is you can sub in x equals -6 into, your equations, whatever equations you have. So the first one, the original one over here, and then solve for k. The problem with that is you still have y and k, so two variables but only one equation doesn't work. So you want to sub in x equals -6 into another equation, and you want to sub into this equation right here, this first equation, okay? So the one that has a y, and the reason why we do that is once you sub in -6, you can solve for y, and when you solve for y, you can sub that y back into this equation. So it's like a lot of substitution. And then you solve for y, and then you can definitely solve for k once you sub in the y, right? Actually, this equation, the simplified version, okay? So let's do that. We sub in -6 into the first equation, so -6 over here equals to -6y squared, so y squared equals to 1, therefore y equals to plus minus 1. Okay, so that's two values, okay? It's two values of y. We'll use both of them to sum into the second equation. So 216y, 1 to the power of 6 plus 4, 1 to the power of 3, plus k equals to 0, and then you have 216 -1 to the power of 6 plus 4 times -1 to the power of 3 plus k equals to 0. So 216 times 1 to the power of 6 is 216, 4 times 1 to the power of 3 is just plus 4, and then plus k equals 0. Then k equals to -220, because we're just going to move 216 plus 4 over to the other side, and that should give us -220. And then same thing over here, -216, oh no, that should be +216, and then -1 cubed is -1, times 4 is -4, plus k equals to 0. So therefore, k equals to -212. Okay, so these are your two answers. So when k equals to -220 and k equals to -212, your tangent, so the vertical tangent right here, would be at the point x equals -6, and then of course you sub in the x to get the y value, right? Sub in the x over here, sub in the k values over here, you get the y value, so that y value. Okay, so that's how this question works. It's a little bit confusing, a lot of things to work out, but it's important that you understand how it works, okay? So hopefully this video helped you solve this question, and aside from that, guys, thanks for watching, and I'll see you in the next video.